everyone, this is Purnavalli, Assistant Professor, Department of Mathematics and SNS College of Technology. So in this video we are going to discuss about the Parseval's identities application through design thinking. So first of all, Parseval's identity is a simple result from Fourier series. Live signals like music or sound can be represented in two ways, which is time domain and frequency. So here our question is, our goal is to find whether energy remains the same in both representation, which is time and frequency. So here is our team who is going to explain the same in detail.
Good morning everyone. Today we are going to explain the Parseval identity using design thinking. First, empathize. First, let us understand the problem. In real life, signals like music or sound represented in two ways: time domain and frequency domain. For example, when we listen a song, we can hear in time, but engineer analyze its frequency. It creates a question: does energy of signal changes when it converts? Understanding this problem is important in engineering and mathematics. So our goal is to find whether energy remains in the same both representation.
Now let us define a problem clearly. We want to prove that the total energy of the signal remains the same, whether we can do it by time domain or frequency domain. So over here when the Parseval's identity comes into picture, we want to prove that total energy of a signal remains the same. We can do it by time domain or frequency domain. Over here when the Parseval's identity comes in the picture, it is nothing but show it. Parseval's identity defines that the energy is conserved. So in mathematical words, it can be said that it is only to change the representation and not the energy.
And the next one is ideated. To understand this concept easily, we can imagine creatively. First, imagine the pizza. When we cut the pizza into the slices, each slices represents the frequency component. Even though the pizza is divided into the pieces, the total quantity of the pizza remains as the same. Similarly, when a signal is broken into the frequency using the Fourier series, the total energy is still the same. The simple idea helps us understand the Parseval identity in an innovative way.
Now, let me explain the formula in a very simple way. Parseval's identity tells us that the energy signal calculated in the time domain and the frequency domain are both the same. So even though the formula looks a bit complex, this idea is very simple. Both sides give the same energy value. So signal calculated in time domain is equal to the energy calculated in frequency domain. So this proves that energy does not change, only the form of representation changes.
Finally, let us test and conclude. Parseval identity is widely used in real-world applications like signal processing, image compression, audio systems. Engineers use these concepts in real-world experiments like analyze and process data efficiently. After testing in many applications, it is confirmed that the energy used in both are same. So we conclude Parseval identities are very powerful.
In today's digital world, we use large number of images in mobile phones, social media and website. High quality image takes lot of storage space and also requires more internet data to share. This creates a real problem for user and developer. We need a method to reduce the size of image while still maintaining their quality. So the main challenge is to compress image efficiently without losing important information.
Now let's define the problem. So when we compress an image, there is always a risk of losing its clarity. Now let's define the problem. When we compress an image, there is always a risk of losing its brightness, clarity and color. So how can you reduce by using this theorem? So the mathematical word is the energy of the image. So basically the question is, we need the brightness, color and clarity while compressing an image.
Next one is ideate. To solve this problem, we use a creative idea. Instead of working directly on the image in its normal form, we convert it into the another form called the frequency domain. In this domain, the image is represented as the different frequency components. Important parts of the images are stored in low frequency component, while less important details are in the high frequency components. By removing or reducing the less important frequencies, we can compress the image. This idea helps us reduce the size while keeping the main features of the image.
Now, let us connect this idea with Parseval. This identity tells us that the total energy of a signal remains same in both time domain and frequency domain. In this case of images, this means that the total energy in this frequency components is equal to the original image. Because of this property, we can safely transfer transform the image and work in frequency domain without losing important information. This acts as a prototype solution.
Test and conclusion. Finally, we test our solution by reconstructing the image after compression. We observe that the image quality is still good, even though the sample size is reduced. The method is widely used in real-life applications, such as image compression, video streaming, and digital compression. So we conclude that the Parseval identity plays an important role in ensuring energy preservation, which helps in design an efficient and reliable system. Thank you.
Now, let us see the overall conclusion. In conclusion, Parseval's identity is an important mathematical concept that ensures the total energy of a signal remains same in both time and frequency domains. By applying the design thinking approach, we understood the real-world problem of image compression, explored creative solutions, and used this identity to ensure no important information is lost. This shows that how mathematics is not just theoretical but also highly useful in practical applications like image processing, communication, and technology. Thus, Parseval's identity helps us design efficient, reliable, and innovative solution in modern engineering. Thank you.